Section 3.5, the 5-number summary in box plots. Objectives. By the end of this lesson, we want to be able to compute the 5-number summary and then draw and interpret box plots. Now, let's consider what we've learned so far. In Chapter 2, we discussed the techniques for graphing representing data. These summaries included bar graphs, pie charts, histograms, stem and leaf plots, and time series graphs. In sections 3.1 to 3.4, we presented techniques for measuring the center of a distribution, spread in a distribution, and relative position of observations in a distribution of data. Why do we want these summaries? What purpose do they serve? Well, we want these summaries to see what the data can tell us. We explore the data to see if they contain interesting information that may be useful in our research. The summaries make this exploration much easier. In fact, because these summaries represent an exploration, a famous statistician named John Tukey called this material exploratory data analysis. Tukey defined exploratory data analysis as detective work, numerical detective work, or graphical detective work. He believed exploration of data is best carried out the way a detective searches for evidence when investigating a crime. Our goal is only to collect and present evidence. Drawing conclusions or inference is like the deliberations of the jury. What we have done so far falls under the category of exploratory data analysis. We have only collected information and presented summaries, not reached any conclusions. Objective 1. Determine the 5-number summary. Now remember that the median is resistant to extreme values, so it is the preferred measure of central tendency when data are skewed right or skewed left. The 3 measures of dispersion that are not resistant are the range, standard deviation, and variance. The interquartile range is resistant. However, the median, Quartile 1, and Quartile 3 do not provide information about the extremes of the data. For this, we need the smallest and largest values in the data set. The 5-number summary of a set of data consists of the smallest data value, Quartile 1, the median, and Quartile 3, and the largest data value. We use the 5-number summary to learn information about the extremes of the data set. Now the summary is organized as follows. You have the minimum, you have Quartile 1, you have the median, Quartile 3, and then the maximum. Okay, now for this next example, we want to be able to then obtain the 5-number summary. Now the table below shows the finishing times in minutes of the men in the 60 to 64-year-old age group in a 5-kilometer race. Determine the 5-number summary of the data. Now the 5-number summary includes the minimum data value, Quartile 1, the median, Quartile 3, and the maximum data value. We use the procedures for finding quartiles. So, step 1, we want the data in the ascending order are as follows. So we're going to put the data in ascending order. So here we put them in ascending order, from 19.95 all the way to 54.3. Okay, so when we take a look at the next one here, we want to, in step 2, we want to find the smallest number. So the smallest number, which is the fastest time in a data set, which is 19.95. Okay, and then the largest number in the data set is 54.63. Okay, now in step 4, okay, we need to count how many observations do we have. Well, there are n equals 21 observations. So the median, or the second quartile, Q2, is going to be the middle observation. So that means this is exactly in the middle. So since that number is exactly in the middle, then we're going to then denote that 30.95 is going to represent Quartile 2, or also the median. Okay, next, in step 5, we now want to find Quartile 1. So the median of the bottom half of the data is the first quartile, Quartile 1, which is the 4th and 5th observation. So we know that the bottom half of the data represents those numbers here. This is the bottom half. So here we have the bottom half of the data. And so what are the number of observations in the bottom half of the data? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we're going to take the two middle numbers and then divide it by 2 to get 26.055, and then we round it to 26.06. So now we have quartile 1. Now we need to determine what is quartile 3. So to determine quartile 3, we now need to look at the top half of the data. So here is the top half of the data. So the median of the top half of the data is the third quartile, quartile 3. So here we have the top half of the data. And therefore, we now need to determine what is the median of that. Well, we know that there's 10 numbers as well. So it's going to be the fourth and fifth observation, the two middle numbers that we need to add together, divide by 2 to get 37.24. So what we determine now is the minimum, which is 19.95, quartile 1, which is 26.06, the median, which is 30.95, quartile 3, which is 37.24, and then the maximum of 54.63.